All right, thanks for joining us and welcome back from your coffee or snack break, depending on where you are in the world. We see that we have an audience from all over. We also have speakers from all over. We had our previous speakers from the United States, the Netherlands, and even from New Zealand, where it was very, very early. Now we're ready to welcome Brian Hilton. He's a global VDI technical solutions architect at Cisco. He's joining us from Nashville, where it's actually, what time is it there, Brian?
Actually, no, I flew into Texas this week, so yeah, normally based out of the Nashville area, but visiting the great state of Texas this week. So definitely appreciate the introduction, Mark, and thank you everyone for taking the time to join us today. As Mark said, my background is in the VDI space. I work for Cisco. I've been a technical solutions architect almost up to 3 years now. Been with Cisco for an extended period of time. As we talk about just for a tech professional background, I've been in the industry for, probably over 18 years now, it seems. And, you know, I work closely with partners, customers, internal sales teams, external sales teams, basically understanding how to best architect and design virtual desktop solutions on UCS and on Cisco HyperFlex. Today we're going to be talking about some of the challenges that a lot of the customers that I speak with have been facing as they've started looking into Windows 10, Server 2016, Server 2019, RDSH deployments. And we're going to talk about how our partnerships with Login BSI and with NVIDIA are really helping customers overcome a lot of the challenges that they're facing. On the personal side, I'm married to my beautiful wife, and we have 2 awesome boys that are all boy, they keep me busy. We also have a dog that is like a ninja. I have this picture here where he's pretending to be a bunny to try to steal the Easter candy. He definitely can grab a plate of food as soon as you set it down without you even knowing he got it. And I'm also Batman, just in case you were curious. No, I was Batman for my youngest son's birthday, and he had a great time. He didn't realize it was me for the longest time. So let's go ahead and get started. So we have a lot of customers that are coming to us after migrating to Windows 10 and telling us that they're still seeing some pretty significant performance challenges on the end user experience. And a lot of that is not tied specifically to the hardware being taxed on the back end. It's more about the end user experience as a whole. So a lot of customers are starting to run dual monitors, sometimes even 4K displays. They're trying to repurpose their existing hardware as an endpoint for rendering those remote routing protocols. And this is information from a Lakeside SysTrack report. It's publicly available. I include the link at the bottom of the slide there. But basically what they found was that when customers move from Windows 7 to Windows 10, the applications that run within that Windows environment are really drawing a significant demand for hardware offload feature sets, hardware acceleration. A lot of customers know it as GPU utilization. You look at every device today that pretty much we consume has an integrated GPU. Even the phones that we carry can now display a 4K resolution. And you know, a lot of the laptops and tablets that we have also have that high performance display capability. So what Lakeside found was that Chrome and Firefox typically consume anywhere from 36 to almost 60% more GPU in Windows 10 than Windows 7. And your traditional Office applications, so just Excel, PowerPoint, Outlook, are consuming anywhere from 52 to almost 85% increase in GPU utilization between Windows 7 and Windows 10. Now, what's not depicted here is also the deltas between the first version of Windows 10 when it first released all the way up until, I think, 1803 or 1809. The performance deltas just between the updates to Windows has significantly had a tax on the hardware as well. So a lot of customers are coming in and saying that they're seeing the same things within their organizations. They're doing a lot of web-based training. They're doing a lot of YouTube videos and just lot more than we've done in the past. And the traditional virtual CPU model can't handle the co-processing that these applications demand. So I love to prove things out in a lab. So this is an example of a WebGL-based website. Okay. On the left, we have a Windows 10 build 1607 image, 2 vCPU, 4 gigs RAM. On the right, we have the same image, same build, but this time we don't have a virtual GPU tied to that virtual machine. On the left, you can actually see with that window open, the only thing that's open is that browser. And we're consuming about 28% virtual CPU by just having that browser open. On the right-hand side, again, we just have that browser open, and of course, device manager showing the deltas between the hardware. And you can see that my CPU is actually spiked to 96% normalized without a virtual GPU. So a significant tick, but what you can't see here is the difference in end user experience. So what I have on the left is a very fluid display. On the right, it's very choppy. The keystrokes aren't easily recognized every time I try to open up, say, Task Manager or Windows Explorer. They just don't always register. So I definitely had a much better end user experience on the left-hand side than the right-hand side. Now, we can't control what websites our end users go to for the most part. You can do some filtering and some proxying, but at the end of the day, there's going to be developers out there, internal to our organizations and external developers, that are writing these websites that really are designed for an excellent end user experience. And they're designed for applications that are living on a physical desktop typically, which most of the time has a physical GPU. So what we've done is within our UCS and HyperFlex portfolio, we've GPU enabled all of the nodes that we can support that are typically seen within a VDI workload. So over on the left-hand side, upper left-hand side, you see our blade form factor, the B480 M5 and B200 M5. Both of those form factors, we can support either 2 GPU in the B200 M5 or 4 GPUs in the B480 M5. Now, every GPU has a different use case. So we'll talk about NVIDIA's Tesla line of GPUs and the use case specific to VDI and virtual workstations coming up later in the discussion. But just a high level, a lot of customers traditionally went down a blade form factor path with VDI in the past. We're seeing now customers start to move into a rack mount form factor moving forward because of things like hyperconvergence and also the additional GPU form factors that you can fit in a rack mount form factor. So under the blade form factor, you can see our HX240C M5, that's our HyperFlex, our own hyperconverged offering. We can support 2 GPUs in a full height, double width GPU form factor, or up to 6 GPUs in a single width half height form factor. Over on the right, C240 M5, same form factor, 2RU form factor as the HX240C M5. Again, same specs on GPU support. The C220 M5 is a 1RU system, and that can support 2 half height single width GPUs in that. What's really cool and unique about our HyperFlex platform is on the bottom you see our HX data platform nodes, if you will. They have the storage integrated into the nodes. You can start off with as few as 6 drives and then expand the drives in the nodes, or you can just add additional nodes that have storage in them to the cluster. We can also take any of these additional nodes that you see on the screen and add them as compute-only nodes to the cluster. So you don't have to actually populate all the storage in a compute-only node. You basically just have to have enough storage for the hypervisor, and basically the VMs that will be running on the hyperconverged node will have that shared storage across the hyperconverged platform. And again, that's HyperFlex. So we do have some links to that, and I can also add some more comments at a later time as well. So as we start to look at GPU adoption for VDI, there's several different ways that customers consume GPUs. If you look over on the left here, we have the NVIDIA M10 that has 4 NVIDIA GPUs with 640 CUDA per GPU. Okay, so 4 GPUs on the card. We can support 2 cards per host. Okay, so each GPU has 8 gigs of frame buffer. So the total for the card is 32 gigs of frame buffer. Now, bear with me a while. This is a lot of information that will make sense a little bit later if you're not familiar with GPUs. But the frame buffer is your first not to exceed value when sizing for graphics accelerated virtual desktops. Okay. We'll talk about that a little bit later. Your traditional knowledge worker and also some RDSH scenarios. So if you're using Citrix applications and RDSH, multiple users connecting to a single VM, if you will, it's a great use case for that. Now, for customers that are more graphics oriented using higher end applications, Slumber, CATIA, SolidWorks, a lot of those applications really demand a lot of CUDA. They're CUDA aware. Okay, so with those applications, we typically recommend the NVIDIA T4, P40, or P6. Okay, again, depending on the application, each has its own variation of benefits, and we like to work with customers to understand what their application needs are before we actually make a recommendation on which GPU they're going to start to look at. Again, the P6 is the blade form factor, so that goes into that B200 that we talked about earlier and the B480. And again, we can support 2 P6s on a blade in a half-width blade form factor, the B200, and we can also support 4 in the B480 M5. So now let's talk about how customers are consuming this based on 4 different models, if you will. Over on the left, you can see that we have our blade, our B200 M5. So for customers that went ahead and made a purchase on a blade form factor for VDI and they started experiencing some performance deltas that couldn't be handled from a CPU perspective, they can drop in 2 NVIDIA P6s and we can help support up to 32 graphics accelerated VMs per blade with a traditional knowledge worker. Okay, those traditional knowledge workers consume about 1 gig of frame buffer each. So your not to exceed value when sizing this out is always going to start with frame buffer. You also want to make sure that you can tolerate a host failure or a maintenance window so that you can actually vMotion these VMs to another host within the cluster and allow that other node's firmware to be updated or any support that needs to be done to the node while not impacting your users. Now, if you look at RDSH, what we typically recommend is taking one of the GPUs and allowing a single VM access to the GPU or maximum of 2. We really like to allocate about 8 gigs of frame buffer for those RDSH VMs because you're basically already sharing all that frame buffer with all the sessions that are connecting to that guest. So we definitely like to not over complicate and over rotate on the way that we lay out the server VMs within an RDSH scenario. If you're looking more towards the high-end designer, they're not doing live rendering or things of that nature, but they still need a little bit more power, if you will. We typically see those users around 4 to 8 virtual CPUs, 16 to 32 gigs of RAM per user, and about 2 to 4 gigs of frame buffer per user. And again, depending on how much frame buffer you allocate per user, that's going to give you your density, okay? So you can see when we start talking in the rack mount form factor, we have a lot more options. You can see over on the left that we can support up to 240 users per host, assuming 30 users per VM, 8 VMs living on a host. So pretty significant amount of users consolidated into a host. Again, if you're doing true VDI, each user's getting their own Win10 image with 1 gig of frame buffer each. You're looking at about 64 graphics accelerated VMs per host if you use a C240 M5 or HX240 CM5 with the NVIDIA M10 GPUs. And again, the designers, we have a lot more flexibility on the GPUs that we could support there. So 6 P4s or T4s, depending on the application set, going all the way up to the V100s for really high-end users that may be using some of those live rendering models. So if you want to test this, we actually have created an environment for basically customers to test this out in dcloud. So you can actually go to dcloud.cisco.com, log in with your Cisco credentials, and basically test Windows 10 with a GPU and without a GPU from your own environment. So you can actually install the Citrix receiver client and basically have a side-by-side comparison of the Windows 10 experience with a GPU and without a GPU. Okay. This is just a high-level overview of that dcloud environment. So we have HyperFlex cluster in 3 different locations across the world. We have 2 compute-only nodes with NVIDIA M10s attached to that cluster. And then we have basically the Citrix Cloud as our broker for handling the Citrix Director and Storefront and all the connections for those VMs. If you're not familiar with our CVD tool, that's our Cisco Validated Design tool. Okay, that's basically a methodology that we use to test virtual desktops at scale. We leverage login DSI for these tests, so we actually put the results in our CVDs of what it looks like to run, up to 5,000 desktops or more on a given architecture. So if you go to cisco.com/go/VDI-CVD, you're going to have this design navigator, and you'll just basically select your platform, whether you're doing Horizon or Citrix, select your hypervisor, the number of seats you want to deploy, and your storage platform. So we have our converged infrastructure stack partnerships, as well as our hyperconverged platforms. We also include a section for graphics, which goes over in detail what I've been describing today about Windows 10. And then I also wanted to include a couple links that you can go to after today's call, and feel free to reach out to me if you have any questions. You can follow me on Twitter. I'm happy to connect with you on Twitter. My handle at VDI_geek. So feel free to drop me a note, and definitely appreciate your time today, and hope you have a great week.
Thank you very much, Brian. I've learned a lot. It was very interesting. Also, I do see that there are questions in the chat. I will make sure those get to you, Brian, because we're running out of the time and it's a pretty complicated question. However, there's also a Cisco booth in the expo, so there are experts there as well. If you want advice, just log on to the expo floor, ask your question there, and Brian or his colleagues are happy to help you out. Again, Brian, thanks so much for joining us. For those of you who have been attending this session, you can now go back to the auditorium and jump over to Rob Girard from Tintri, talking about solving bottlenecks in virtualization. Thank you very much and have a great day. Take care. Bye-bye.
Thank you.